Okay, everybody, this video is going to be all about free fall. So when objects are moving vertically, okay? So an object is in free fall if gravity, meaning Fg, is the only force acting on it. Okay. So when an object is in free fall or moving vertically, we automatically know that the acceleration of the object is going to be equal to the acceleration due to gravity, okay? Which for us on Earth is 9.8 meters a second squared. And since acceleration is a vector, we say that the g value is a negative 9.8 meters a second squared. So any object that's moving vertically that doesn't have air resistance or drag forces or anything like that will have an acceleration of negative 9.8 meters a second squared. So there's three types of problems really within the free fall category. Okay? There are dropped objects. Okay? There are objects that are thrown down, and there are objects that are thrown upward. Okay. If an object is dropped, our initial velocity is 0. That's an assumption that we can make. Our acceleration is g, or negative 9.8 meters a second squared. And we might be asked to solve for the height or the distance the object travels, the time it takes to fall, or something like that. Okay. When an object is dropped, though, d needs to be negative because the object is falling down, and down is a negative direction. Okay. When an object is thrown downwards, the initial velocity has some negative value. Again, negative because it's thrown down. The acceleration is g, is negative 9.8 meters a second squared. And again, same thing here, since we're traveling downward, d needs to be negative. Okay, so the first two here are pretty similar. Okay, we have acceleration that's negative, we have a negative displacement. Objects are moving downwards. An object thrown upwards is a little bit more complicated. Here, our initial velocity is a positive value, and our acceleration is negative 9.8 meters a second squared. So what this means for us is on the way up, the object slows down, and on the way down, when we have a negative velocity, the object speeds up. Okay. So what our object does is it slows down when it on the way up, speeds up on the way down. Okay. Now because this object changes direction of travel, it must stop at some point, because in order to change directions you have to stop, just like in a car. So changes direction of motion, right? We go from moving up to moving down. So what this means for us is we stop at the top, okay? Which means the velocity at our maximum height, or the velocity at the peak, is 0. The reason why that's super useful to us is because we can treat this VP, or velocity at the maximum height, as a V final in our equations to help us find things like the maximum height we might reach to, the t, or the time it takes to get to the top, and things like that. When an object is launched straight upwards, it undergoes something called symmetry, okay? Which means the time it takes to get to the top and the time it takes to fall back down are the same. Okay? Oops. That should be t top. Okay? So if we want to find the total time of flight, and say we already found the time it took to get to the top, we would just multiply that t to the top by 2. Okay, because the time it takes to get up and the time it takes to get down is the same. Okay. This is h max. Now, that symmetry also applies to the velocity. So if we are launched upwards with a speed v, then just before we hit the ground, we will have a downwards velocity of the same magnitude as our original upwards velocity, assuming we land on the same plane. Okay? The only difference is that the ending one will be negative because the object is traveling downwards. Okay? Some important points to recognize is that the acceleration is a constant negative 9.8 meters a second squared throughout. So it doesn't matter where the ball is on its flight path, the acceleration is always that negative 9.8 meters a second squared. Even when the velocity is 0 at the top, the acceleration still has a value of 9.8 meters a second squared. If it didn't, then the ball would just hang out in the air, and that doesn't make any sense. Okay. And that is it for the basics of free fall. So let's go through a problem or two. So remember, g is 9.8 meters a second squared. So what is the velocity of a dropped object after it's fallen for 3 seconds? So if the object is dropped, our initial velocity is 0. We are looking for the final velocity. Time is 3 seconds, and acceleration is negative 9.8 meters a second squared. The only equation that has those 4 and only those 4 variables in it is v equals v0 plus at. So I'm going to use that equation. v0 is 0, a is negative 9.8 meters a second squared times 3 seconds. That gives me a velocity value
Is there a problem
of 29.4 meters a second, and really it should be a negative. And again, that negative just means we are moving downward. So another example, a ball is thrown straight up with a velocity of 16 meters a second. What's its velocity 2 seconds after being released? Okay. So for number 2, we have an initial velocity of positive 16 meters a second because we're thrown upwards. My time is 2 seconds, acceleration of negative 9.8 meters a second squared, and I want to know what the final velocity is. Okay. So I use the same equation that I did before, and v is what I'm looking for, so I plug in 16 meters a second plus negative 9.8 meters a second squared times 2 seconds. So 16, 9.8. So that gives me negative 3.6 meters a second. So that means that this object has already changed direction. We're moving back downward at a speed of 3.6 meters a second. Let's see. So let's actually, for number 2, let's figure out how high that ball goes. So let's say I now want to know my height. Okay. Well, at the maximum height, remember that my velocity is 0. So instead of using this negative 3.6 or even negative 16, I would use the velocity of the peak as 0. And I can use v squared equals v0 squared plus 2ad to help me solve this question. So v is 0. The initial was a positive 16 meters a second. A is negative 9.8. And I'm looking for my distance. Okay. So I square 16 and then subtract that from both sides. So I get negative 256 is negative 19.6 times d. Divide both sides by that negative 19.6. And I get a maximum height of approximately 13 meters. And notice how I get a positive answer out. That's because that is a 13 meters upward. And that's the basics of free fall as far as we're concerned.